Good day, everybody. How are you all? Today we are going to discuss about confidence interval calculations. So here I go. We use sample data to make generalization about an unknown population parameter. This part of statistics is called inferential statistics. Why? Because we are using sample data to make predictions or forecast about population characteristics. So we are drawing inference or conclusion from the sample data and making prediction or forecast about population characteristics. So it is to draw inference, to draw conclusion about the population characteristic based on sample data. The sample data help us to make an estimate of the population parameter. The sample mean is given by X bar is the point estimate, means single value from a single sample. The sample mean is a point estimate for the population mean mu. Remember, X bar is called a statistic. The point estimate is not the exact value of the population parameter, but close to it. After calculating point estimates, we construct interval estimates called confidence intervals. The interval of numbers is a range of values calculated from a given set of sample data. The confidence interval is likely to include an unknown population parameter. What are they saying? We're saying we'll have a sample, collect a sample, get the sample mean. From the sample mean, we'll estimate a range of numbers within which most probably the population parameter or population mean in this case will fall. Range of numbers means it's an interval of numbers with a lower boundary and an upper boundary. To construct a confidence interval for a single unknown population mean mu, where the population standard deviation sigma is known, we need X bar as an estimate for mu, and we need the margin of error. Here, the margin of error, okay, or error bound for a population mean, okay. The sample mean X bar is the point estimate of the unknown population mean mu. So sample mean is the point estimate of the unknown population mean mu. The margin of error or error bound of the mean depends on the confidence level, abbreviated as CL. The confidence interval will have the form. So we have a point estimate coming from the sample, that is the sample mean. The lower boundary of the confidence interval within which most probably the population mean will be fall is X bar minus EBM, which is the error bound for the mean, okay, error bound for a population mean, also called margin of error. So it's X bar minus margin of error at the lower end and X bar plus margin of error at the upper end. Suppose we have collected data from a sample. We know the sample mean, but we do not know the mean of the entire population. The sample mean is 7 and the error bound for the mean is 2.5. The sample mean X bar is 7 and error bound for the mean is 2.5. This is also the margin of error. So what is the margin of error? It is the difference between the sample mean and the population mean. So your confidence interval, the lower boundary will be sample mean minus error bound for the mean or margin of error. That is 7 minus 2.5, which is 4.5. And the upper boundary for the confidence interval will be 7 plus error bound for the mean is 7 plus 2.5, 9.5. If the confidence level CL is 95%, then we say that we estimate with 95% confidence that the true value of the population mean is between 4.5 and 9.5. Again, 4.5, the lower boundary comes from the fact that from the sample mean, we subtract the error bound for the population mean, which is also called margin of error. That is 7 minus 2.5, which is 4.5. And the upper boundary for the confidence interval is sample mean plus the error bound for the population mean, which is 7 plus 2.5, which is 9.5. And if the confidence level is 95%, we can state with 95% confidence, we can state that the actual population mean is between 4.5 and 9.5. Suppose we have a data from a sample. The sample is 15 and the error bound for the mean is 3.2. What is the confidence interval estimate for the population mean? Well, it will be 15 minus 3.2 at the lower boundary, which is 11.8. And the upper boundary will be 15 plus 3.2, which will be 18.2. So what if we aren't given X bar and the error bound for the mean? How do we form X bar minus error bound for the mean? How do we find the lower boundary, which is X bar sample mean minus error bound for the mean, and X bar plus error bound for the mean, which is the upper boundary of the confidence interval? We have many ways, preferably using the calculator, to find the sample mean X bar if it's not given to us. The error bound formula for an unknown population mean mu, when the population standard deviation sigma is known, is z alpha by 2. Error bound for the mean is z alpha by 2 times sigma divided by square root of n. Sigma is known. The part that is challenging is to find z alpha by 2. Z alpha by 2 is called the critical value of z. It is the value of z. It is called critical value of z because it separates the most probable region within which the population mean will fall, which is in the center of the normal distribution, standard normal distribution, from the least probable region, which are in the two tails, where most probably the population mean will not fall. Remember, sigma is the population standard deviation, which is known. N is the sample size. Specifically, sigma, population standard deviation, divided by square root of n, is the standard deviation of the probability distribution of the sample mean. Okay, so sigma by square root of n is called sampling error, which is the standard deviation of the probability distribution of X bar. That is, X bar is on the horizontal axis and probability or relative frequency on the vertical axis. We get a bell-shaped curve of the probability distribution of X bar, and its standard deviation is sigma divided by square root of n, where sigma is the population standard deviation, n is the sample size. Remember the margin, error bound for the margin of error bound for the mean or margin of error depends on the confidence level, abbreviated CL. The confidence level CL is the area in the middle of the standard normal distribution. So confidence level is 1 minus alpha. So alpha is the area that is split equally into two tails. Each of the tails contains an area equal to alpha by 2. So the area in the center, where most probably the population mean will fall, is your confidence level, which is 1 minus alpha. So the area in the two tails, which is not shaded white area, is equally divided among alpha. So each tail is alpha by 2, alpha by 2. Now the question is, suppose your confidence level is 0.95. Then alpha is 1 minus 0.95, which is 0.05. And alpha by 2 is 0.05 divided by 2 is 0.025. So we want to find z alpha by 2. Okay, z alpha by 2 is the critical value of z on the right of the center, and minus z alpha by 2 is the area on the left tail. Okay, now the area in the right tail, the area to the right of the critical value is 0.025 in the right tail, and in the left tail, the area to the left of this critical value is also 0.025. Now, if the area in the right tail, which is alpha by 2, which is alpha by 2 is 0.05 divided by 2 is 0.025. So that's the area in the right tail in the white area. So what is the area to the That is the area to the right of the critical value where x bar plus EBM is located. So what is the area to the left of it is 1 minus 0.025, which is 0.975. Now we go to your calculator, our calculator, we TI-84, we press the second key in the top left, then we press verse, which is the third row, which is the key in the right in the third row. Second verse, and then we select 3 in norm. Now we know the area to the left of the x bar plus EBM, which is 0.975. Okay, what is my mean for a standard normal curve? Mean is 0. What is my standard deviation? 1. I go to PEST and hit enter and enter. So that critical value is 1.96, which is Z alpha by 2. Okay. So when we know the population standard deviation sigma, we use a standard normal distribution to calculate the error bound for the mean and construct the confidence interval. Remember, for the standard normal distribution, mean is 0, standard deviation is 1, and we calculate the critical value of Z alpha by 2 by going to TI-84, second verse 3, which is in norm, area to the left is 0.975, then mean is 0, standard deviation is 1, and the critical value works out to 1.96. So the error bound for the mean or margin of error is the critical value of Z alpha by 2 multiplied by sigma divided by square root of n. Sigma divided by square root of n is not difficult because once again sigma is known and we should know the sample size. But because of that piece, we do not need to remember because of that piece, we do need to remember the central limit theorem. So what they're saying, x bar is normal, that is the sampling distribution of x bar, the probability distribution of x bar is normally distributed, okay? And its mean is equal to the mean of the population, mu x is equal to mu, and its standard deviation is sigma x divided by square root of n. Remember, either that x distribution is normal or there must be 30 in the sample space. The interpretation should clearly state the confidence level, explain why the population parameter is being estimated, here a population mean, and state the confidence interval, both the endpoints. And we write it like this. We estimate with, if it is 95% and 95% confidence that the true population mean will fall between the lower boundary and the upper boundary. As a recap, the steps to construct a confidence interval estimate for an unknown population mean when sigma is known. Calculate the sample mean x bar from the sample data if necessary. Find the z-score that corresponds to the confidence interval. Calculate the error bound for the mean or margin of error. And the confidence interval, the lower boundary is x bar minus EBM. Upper boundary is x bar plus EBM. Interpret the estimate in context of the situation of the problem. Okay. Suppose that scores in an exams in statistics are normally distributed with an unknown population mean and a population standard deviation of 3 points. A random sample of 36 scores is taken and gives a sample mean of 68. Find the confidence interval estimate for the population mean exam score, the mean score on all exam. Okay. Find a 90% confidence interval for the true population mean of the statistics exam score. Notice your sample size is 36 greater than equal to 30. The sample mean score is 68, and we want to estimate the interval with 90% confidence within which most probably the population mean will fall. So what will you do? You will press stat, then highlight, that is move with the right cursor key, the cursor on top of test. So stat, then highlight test, and scroll down to number 7, Z interval. We are going to use Z interval when we know the population standard deviation. Okay. So where is this? Okay. So press number 7, Z interval. Input will be on stats because we're not typing the data. Sigma is the standard deviation of the population, which is known as, no, not this one. Okay. Sample mean, random sample, find the count, 90%. That is said the distributed with an unknown population mean population standard deviation of 3. So sigma, the population standard deviation is 3. Okay. The mean score for the sample of 36 is 68. Okay. And the sample size 36. And your C level, confidence level is 0.9 for 90%, and we will calculate. So stat, test, and Z test, we are going to, or Z interval. Why we are going to use Z interval? Because we know the population standard deviation. So we type in the population standard deviation of 36, sample mean score of 68, sample size of 36, C level of 0.9, and we calculate. So we get 58.13 as the lower boundary and the upper boundary is 77.87. What does it mean? With 90% confidence, we can state that the actual population mean test score will fall between 58.13 and 77.87. Okay, another problem. Random sample of 28 pizza deliveries. Okay. Suppose average pizza delivery times are normally distributed. Okay. So that means even if the sample size is less than 30, but because the pizza delivery times are normally distributed, the mean delivery times will also be normally distributed. So again, we go to stat, test, and we go down to number 7, which is Z interval, and input data sigma. Our sigma is population standard deviation of 6 minutes, 6. Our X bar, okay, X bar is taken and our sample is 36. Our sample size N is 28. Our C level is 0.9 and we calculate. So with 90% confidence, we can state that the delivery time will be between 34.14 and 37.87 minutes. Okay. So, and again, the same way we do this problem. How do you calculate the sample size for a preliminary estimate? You use the formula N is equal to Z squares times sigma square divided by error bound for the mean or margin of error square. The population standard deviation for the age of foothill college students is 15 years, population standard deviation. If we want to be 95% confident that the sample mean age is within 2 years of the true population mean, that means the error bound for the mean or margin of error is 2. Remember, margin of error is the difference between the sample mean and the population mean. How many randomly selected food? So you use the formula. Now for 95% confidence, we already determined Z alpha by 2 is 1.96. So it will be parenthesis, put the parenthesis. I'm going to use this formula. Z is 1.96 times sigma. Sigma is 15, okay, divided by error bound for the mean is 2 years. So what did I do? I put a left parenthesis. Inside the parenthesis, I type 1.96 for Z alpha by 2 times sigma, which is 15 given in the problem statement, then divided by 2, which is the margin of error. Put the right parenthesis now after the 2, then press the X square button, which is on the first column of TI-84 halfway down, and then press enter. Now we get 216.09. You do not round it down to 216. You round it up to 217. Okay. Suppose we do not know the population standard deviation. Okay. Then what we're going to do? Okay. So we are going to use a different distribution. In practice, we rarely know the population standard deviation, sigma. When the population standard deviation is unknown, we do not use the standard normal distribution. Rather, we use the student's t distribution. That is similar to the z distribution, which is the standard normal distribution. But when the sample size is less than 30 and the population standard deviation is not known, then we use t distribution. There is the one big difference in the calculation using the z distribution and the t distribution. Remember, t distribution, when we do not know the population standard deviation, is for the t distribution, we have to take into account n minus 1, which is sample size minus 1, which is called degrees of freedom. The notation for the student's t distribution using t as the random variable is t given by t df, where df is n minus 1. For example, if we have a sample of size 20 items, n is 20, then the degrees of freedom is 90. And we write t as a distribution, normal distribution with t, 19 degrees of freedom. With the student's t distribution, there is a t-score which has the same interpretation as z-score. A probability distribution, no, we use the calculator. Okay, we are not going to use the table. The formula for the error bound for the mean or the margin of error, in this case, z alpha by 2 is represented by t alpha by 2. Again, this is the critical value of t, which separates the center, which is the most probable region, from the least probable region in the two tails. Okay. And remember, alpha is 1 minus the confidence level. So area in each tail is alpha by 2. So you get the critical value of t for that degrees of freedom, which is n minus 1, multiply it with, instead of population standard deviation, sample standard deviation divided by square root of the sample size. T alpha by 2 is the t-score, with the area to the right equal to alpha by 2, use degrees of freedom n minus 1, sample size minus 1, and S is the sample size. The format is x bar minus error bound for the mean and x bar plus error bound. So these are the information. Suppose you do a study of acupuncture to determine how effective it is in relieving pain. You measure sensory rates for 15 subjects with the results given. Use the sample data to construct a 95% confidence interval for the mean sensory rate for population. Assume normal from which you took the data. Notice here that sample size n is 15, much less than 30. Further, we do not know the population standard deviation. Therefore, we cannot use the z distribution. So we have to use the t distribution. But before doing that, we have to enter the data in L1 of the calculator. So first thing we do is press the second button, then the plus button on top of enter on the bottom right, second button, plus button on the bottom right, on top of the enter button, then number 4, clear all list on your calculator, hit enter, done. Then stat button and then 1. So 8.6, then 9.4, then 7.9, then 6.8, then 8.3, then 7.3, then 9.2, then 9.6, then 8.7, then 11.4, then 10.3, then 5.4, then 8.1, then 5.5, then 6.9. So we have 15 data points which we entered in L1 of the calculator. So we have to calculate the 95% confidence interval for the population mean. So what do? We press the stat button, then highlight test as before, And we scroll down to t interval. This time we will use t interval because we do not know the population standard deviation. Further, sample size is less than 30. So go on t interval and hit enter. So now the input on the first line, bring the cursor by the left cursor key on top of data and hit enter. So if you're having problem in understanding the instructions, how to use the calculator, I will also show you some YouTube videos, okay? Input is on data, list is L1, frequency is 1, okay? List is L1 is automatically there. We entered the data in L1, frequency is 1, each data point is entered 1 times only. C level is now 0.95, 95% confidence. And we calculate. So with 95% confidence, we can state that the actual population mean will be between 7.30 and 9.15. Same idea over here too. Okay, they show you how to do it using the calculator. Again, same. This is also the population standard deviation is not known. You have the data, enter the data in L1, and then you do stat calc and you select t-test because the population standard t-interval rather. You do not know the population standard deviation and the sample size is less than 30. Okay. 98% confidence level. Let's do this. Second button, then plus on top of enter, then number 4. Clear all list, done. Then stat 1. In L1, we are going to enter this data 0, 3, 1, 20, 9, 5, 10, 1, 10, 4, 14, 2, 4, 4, and 5. Okay. So now we do stat button, then highlight test. Sample size is less than 30. Population standard deviation is not known. Go to T interval number 8 and hit enter. Input data list is L1. And you have to change your C level to 0.98 and we calculate. So with 98% confidence, we can state that the actual population mean will fall between 2.39 and 9.87. Okay. How do we do the calculation for population proportion? Okay. Example, during an election year, we see articles in the newspaper that state the confidence interval in terms of proportions or percentages. For example, a poll for a particular candidate running for president might show that the candidate has 40% of the vote within 3 percentage points. This 3 percentage point is your margin of error. Often election polls are calculated with 95% confidence, so the pollster would be 95% confidence that the true proportion of voters who favored the candidate would be between 0.4 minus 0.03, which is 0.37, and 0.4 plus 3 is 0.43. The procedure to find the confidence interval, the sample size, the error bound, and the confidence level for a proportion is similar to that for the population mean, but the formulas are different. How do you know you're dealing with a proportion problem? First, the underlying distribution is a binomial distribution. There is no mention of a mean or average. If X is a binomial random variable with sample size n and probability of success is P, where n is the number of trials, P is the probability of success. To form a proportion, take X, the random variable for the number of successes, and divide by n. Okay. X is the number of successes, n is your sample size. And this is called P hat, okay, sample proportion. And we can show that the probability distribution of P hat is a normal distribution with a mean of NP over N divided by, okay, all those things, okay? So let's, this is the formula for the error bound for the population proportion, and then you use the same as before. The formula is similar to error bound formula for the mean, except that the appropriate standard deviation is different. So the standard deviation of binomial is square root of PQ over N. Okay, let's do this problem. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who have cell phones. 500 randomly selected residents in this city are surveyed. N is 500 and 500 to determine whether they have cell phones. Of the 500 people surveyed, 421 responded yes, they own cell phones. Using a 95% confidence level, compute a confidence interval estimate for the true proportion of adult residents of this city who have cell phones. So what do I go? Press the stat button, then with the right cursor key, highlight test on the top line. Now we are looking for one prop z interval that is not on the first screen. So keep scrolling down with the down arrow key. Still you see one prop z int, which is A as in apple. Once your cursor, the black square button is aligned with A, hit enter, which is one prop z int. Your X is your number of successes, which in this case is 421. N is your sample size, which is 500. What is your C level? Is 0.95. And we calculate. So with 95% confidence, we can state that the actual population proportion will be between 0.81 and 0.87. Okay. Same thing as before. Now we are getting a formula for, okay, for the minimum sample size, which is n equal to z alpha by 2 square times p times q. P is the probability of success, p hat, and q hat is the probability of failure, which is 1 minus p divided by p square. So here's the problem. Suppose a mobile phone company wants to determine the current percentage of customers aged 50 plus who use text messaging on their cell phones. How many customers aged 50 plus should the company survey in order to be 95% confident? Okay. That the estimated sample proportion is within 3 percentage point, okay, of the true population proportion of customers aged 50 plus. So your margin of error is 3 percentage point or 0.03, and you want to be 90% confident. So you need the critical value of Z for 90% confidence. Remember, in this case, confidence level is 90%, so alpha is 1 minus 0.9, and alpha by 2 is 0.1 divided by 2 is 0.05. So alpha by 2 is 0.05. If you do the calculation correctly, critical value of Z will be 1.645. Okay. So how do you do the calculation? Okay. How many? In this case, the population, the sample, a preliminary estimate of the sample proportion of success is not given. So in that case, we assume P hat in this formula is 0.5, Q hat is also 0.5. So it is, how do you calculate? Use this formula. P hat is 0.5 multiplied by 0.5, which is Q hat, which is the probability of failure. Then you put a left parenthesis. Inside the left parenthesis, you put the Z alpha by 2 value for 90% confidence, which is 1.645. And then you divide by margin of error, which is 3 percentage point or 0.03. Close the right parenthesis. So 0.5 times 0.5, left parenthesis, critical value of Z for 90% confidence, which is 1.645. Divide that by margin of error, which is 0.03. close the right parenthesis, and then press the X square button, and then hit enter. And this gives n equal to 752, not 751.67. We always round it up to the next higher number. Okay. So I'm going to stop here today. I will also post some YouTube videos which you can watch to understand how calculations are done using the TI-84. Thanks for watching. Hope you understood the material. If you have any question, you can always shoot me an email or send me a message. I'll get back to you as soon as possible. Thanks for watching. Have a nice day. Take care. See you.